Wild game stories.
Nah.
know.
Oh, we don't want to talk about Austin's game.
It didn't matter.
So we were looking at 13 and we did part 1, part 2, now part 3. So we have to plug in a half. Okay, ready?
No.
Kayla, you with me today? Okay, you might be the only one. So
I'm coming.
oh, you did all of them already? Okay, well let's check them. So if you plug in 1/2 into here for t, half of negative 2 pi is negative pi, and then negative pi minus pi over 2 is negative what? Right, so that would be negative 3 pi over 2. And so I need to find the sine of negative 3 pi over 2. So
we'll have our charts, right? So
you'll
we'll
have your charts, yeah.
Make sure the graph looks like really bad.
You'll have your charts and you'll have a page of notes, so you'll be fine. So here's negative pi, and here's negative 3 pi over 2. So that's going to be 1. So this whole thing comes out to be 1. And so 70 pi plus 70 pi is 145. What you got, Caleb? Nice. Just have you teaching the class. And then now we need to plug in
I just made this really cool class.
3/4 or 0.75. So this is going to be a little bit tricky. What is 3/4 of negative 2 pi?
Huh?
What 3/4 of negative 2 pi? So I'm plugging in 0.75 there. So I'm going negative 2 pi times 3/4 is what? 3/2. Good, because the 2 cancels and makes that 2. So it's negative 3 pi over 2. But then I'm subtracting another pi over 2. So altogether that is negative 2 pi, negative 4 pi over 2, which is negative 2 pi. So if we go to the graph, sine of negative 2 pi is 0. So this whole thing will be 0 plus 70 pi is 70 pi. Okay? And then I have a guess for t equals 1. What is it?
70 or 100.
Going with guessing 0 because we kind of have a little pattern going here. 0, 70 pi, 140 pi, 70 pi. So I'm guessing 0. Let's see if it works. So if I plug in 1 into here, negative 2 pi minus pi over 2 is what? Negative 2 pi minus pi over 2 is negative 5 pi over 2. So I have to figure out the sine of negative 5 pi over 2. So that's going to be this right here, which is negative 1, right?
Yeah.
Okay. So negative 1 times 70 pi is negative 70 pi plus 70 pi is 70 pi. Therefore, so that works out. Okay?
0.
All right, so then for D, we're doing it for the y stuff. I know, it's crazy. So let me write down the y derivative here. Negative 70 pi cosine.
Holy cow.
No.
So y prime of t is negative 70 pi cosine negative 2 pi t minus pi over 2, right? Is that what you guys have? Yeah? Okay, so when t equals 0, y prime of 0, I have to plug 0 in here for t. So now I'm going to need to know what the cosine graph looks like. So that starts at 1 and then goes like this. Okay? So here is negative pi over 2, here is negative pi, here's negative 3 pi over 2, and here's negative 2 pi. So if you plug in 0 in there for t, what do you get? Negative pi over 2, and the cosine of that is 0, so this whole thing becomes 0. Now if I'm going to plug in t equals 0.25, and this would be really easy to do if we could have a graphic calculator, right?
Yeah, because it gives
Do that table thing. Okay, so I have to plug in 0.25, so negative 2 pi times 0.25 is what? Negative pi over 2. And negative pi over 2 minus another pi over 2 is negative 2 pi over 2, which is negative pi. So that's going to be negative 1 times negative 70 pi is
Next one's gonna be 145.
so, huh?
I predicted that was 2 rows.
Okay, so let's see if t is 0.5. Y prime of 0.5, so we need to put in 1/2 here. Negative pi times a half is, negative 2 pi times a half is negative pi. And the negative pi minus pi over 2 is negative 3 pi over 2. And the cosine of negative 3 pi over 2 is 0. And negative 70 pi times that is going to be 0. Okay? And so the reason why that didn't work that time is because the other one had that 70 pi being added onto it. But I'm guessing we can figure out what it is at t equals 0.75. I'm not even going to do it. What do you think it is?
75.
Negative 70 pi, yeah. Because we went 0, 70 pi, 0, negative 70 pi, and the next one is going to be 0 again. Okay? Man, this is a long problem.
When is the first time the horizontal velocity will be? I already forgot what this is about.
It's about that bike and the piece of the chalk mark on the bike. All right, so it says E, when is the first time the horizontal velocity will be a maximum? So we need to find our equation for the horizontal velocity, which was the x prime of t1.
Just before you start.
So 70 pi plus, is it sine of oh, dang it. Plus 70 pi times the sine of negative 2 pi t minus pi over 2. And I want to figure out when that's what? A maximum. So how do we do that? I could graph it, yeah, and see where it's the biggest. I want to use calculus. What? You know how to find the maximum of a function by using calculus.
Isn't it assigned?
It is, yeah.
So then it'll have a top point.
The top point will be when the slope is 0, yep. So how do I find where the slope is 0? Is that what equal to 0? No.
Said t equals
I have to take the derivative of this and set that equal to 0 because I'm trying to find the slope of the velocity, right? When is the velocity the greatest? Not when is the position the greatest. When is the velocity the greatest? So I have to
Take the derivative
of this.
again.
Set that equal to 0. So those cancel. Derivative of sine is negative cosine. It's going to, oh yeah, okay. And then I have to leave the inside the same. Multiply by the derivative of that. So the derivative of this, ooh, that's going to be a pi squared. Negative 2 pi times 70 pi is negative 130 pi squared. Okay? So that is what I need to set equal to 0. So negative 140 pi squared, it's not going to be as gross as it looks. Negative pi over 2 minus pi over 2 equals 0. What do you want to do first? Divide by negative 140 pi squared, right?
Just so I should want to know what one of the biggest questions you girls ever asked me. There's Tara in behavioral studies, she asked me if I wanted to compare calluses.
Yeah.
Kind of the only time you'll ever do that one.
Yeah. That's a little different.
What cares?
But there's a little bit. Okay, so we need the cosine of negative 2 pi t minus pi over 2 equal to 0, right? So what does this stuff inside have to equal so that if I take the cosine of it, I get 0 as an answer? Same. What? Pi over 2 would be the first place that would happen. Yeah?
So 2 would have to be 0.
That would be kind of close, but they're negative, yeah. So I'm going to add pi over 2 to both sides. So negative 2 pi t equals pi over 2 plus pi over 2, which is what? Pi. that means the pi's cancel. But no, that makes it 1, right?
Yeah.
If I divide both sides, then I get negative 2t equals 1. So t equals negative 1/2, but that's no good.
No good,
That's
because
not good, because it's negative sign, okay? So pi over 2 is not good enough. When's the next time that cosine
3 pi over 2.
equals 0? 3 pi over 2?
Yep.
So now let's try setting it equal to 3 pi over 2.
Add pi over 2.
Add pi over 2. This is going to be a problem. So 3 pi over 2 plus pi over 2 is
2.
2 pi.
4 pi over 2, which is 2 pi. And then I divide both sides by negative pi. Negative 2 pi. And what do I get? T equals negative 1. So we're going the wrong direction.
Wrong
Okay?
direction.
So instead of going this way from pi over 2 to 3 pi over 2, where's the time before this where it
0.
equals 0?
Yeah,
Is it negative pi over 2? It's definitely not 0. Here's the cosine graph. Yeah,
Oh.
negative pi over 2 is the other place where that's
Now we're at
0.
0.
So let's do that instead. So I'm going to change this. And now what Ruth said before is correct. Because if this has to equal negative pi over 2,
We'll add pi.
these will cancel. So negative 2 pi t equals 0. So t has to equal 0. Does that count?
No.
No, probably not. Because
One
they
more.
say what is the first time, so not t equals 0.
Negative 3 pi over 2.
So let's set it equal to negative 3 pi over 2.
Why are you recording this?
For source.
Oh yeah, sure.
Negative 3 pi over 2. Okay, so I have to add pi over 2 to both sides.
No, negative pi.
Negative pi. So negative 2 pi t equals negative pi.
Pi.
Yeah.
Divide by negative pi. So those cancel and the negatives cancel. So 2t equals 1. Hallelujah. Which we probably could have figured out just by looking at the pattern of the other answers we were getting, right? Because we got negative 1/2 and we got negative 1 and then we got 0. So it's every, like Julie said, it's a sinusoid, so it's going to have peaks every so often. Apparently that happens every half second.
Sounds like a dinosaur. Power Rangers.
Okay, now we have a problem. Because it says, when is the first time the horizontal velocity will be a maximum? When is the first time the horizontal velocity will be a minimum? So we kind of fudged this a little bit. Because we found out where the slope of the tangent was 0, right? But that could be a maximum or a minimum. So we didn't really solve that problem.
We did?
Nope. So here's what we did figure out though, that at t equals 0, that t equals 1/2, that t equals 1, those are all either maximums or minimums, right? What? Yeah, we basically can make a sign chart with
That's what I
this.
suggested originally.
Oh yeah.
Ruthie is just so smart.
I never listened to you.
Oh my god.
So those are going to be our thingies, and so now I guess it's not too bad from here. I'm just going to plug those in to see what answers we get. But we already did that,
Yeah, we did.
right? What did we get when we plugged 0 into the thingy?
0.
Okay, so at time t equals 0, the answer is 0. What do we get when we plug 1/2 into there? 140 pi. And what do we get when we plug 1 into there? I don't know, I'm asking Kayla.
1, 0, 0.
Kayla, 1 was 0 again? Okay. Okay, so now we can answer, and it turns out we left out, we were right. The answer to E, when is the first time the horizontal velocity will be a maximum? That's right. That t equals 1/2. When is the first time the horizontal velocity will be a minimum?
1.
1. As long as we're not counting 0. Is the answer. What is the maximum horizontal velocity? Oh, we're on roll
So
now.
now I have to put it
But we already did. 140 pi. What is the minimum horizontal velocity?
0.
0.
Now I have to do it for vertical.
Nice. Now I have to do it for vertical, but we already know how to do it. So we're in good shape here.
Chart.
What's the formula for the vertical velocity?
Y prime t equals negative 70 pi cosine negative 2 pi negative
Yeah, 2 pi t minus, okay, so what do I have to do with this?
Take
Take the derivative of this and set it equal to 0. So the derivative of cosine is negative sine. So I've got a negative there, so right now I'm at a positive, right? But then when I divide, or when I multiply by negative 2 pi, it's going to end up being, is it my final answer going to be positive or negative? I'm asking.
Negative.
I got a negative here.
Three negatives.
I've got a negative here when I take the derivative of the stuff inside because of the chain rule, and then I've got a negative because the derivative of cosine is negative, so overall I'm having negative 140 pi squared. Okay, so when I set that equal to 0, just like before, that cancels out. So I just need to know about negative 2 pi t minus pi over 2. I want that to equal 0. When does that equal 0? When does the sine thing equal 0? We better do negative from our last experience. So negative pi.
Negative pi.
So if I add pi over 2 to both sides, that means negative 2 pi t equals negative pi over 2. Right? And then I'm going to be dorky, and instead of dividing by negative 2 pi, I'm going to multiply by negative 1 over 2 pi.
Dork.
And so those cancel. So t equals, the reason I did that is because now the pi's cancel, the negatives cancel, and it's going to be t equals 1/4. Okay?
Can you pause?
I will literally pause right there. Okay, so we better find the next one too, because it seems like we're going to need to know which one's the minimum and which is the maximum and that kind of thing. So where's the next point if we go backwards that the sine function equals 0? Negative 2 pi. What? You think so? It's going to be, we're going to jump over half, you think? Okay. So if I add pi over 2 to both sides, negative 2 pi plus pi over 2 is what? Negative 3/2 pi. And so once again, I'm going to do the same trick and multiply it by negative 1 over 2 pi. So negative 3 pi over 2 times negative 1 over 2 pi. Pi's cancel. Negatives cancel. Did you get it?
Yeah.
Julie's ready for the high five. So the next one is 3/4. And you can see that, well, never mind. All right, so 1/4 and 3/4. So now we have to basically make our little sign chart. So when we plug 1/4 into the y prime thingy, what did we get? What? 70 pi? When we plug 3/4 into the y prime thingy, what did we
You
get?
guessed it.
Negative 70 pi? Okay, so the answer to I, when is the first time the vertical velocity will be a maximum? T equals 1/4. J, when is the first time the vertical velocity will be a minimum? T equals 3/4. K, what is the maximum vertical velocity? Say it. 70 pi. L, what is the minimum vertical velocity? Negative 70 pi. Right? Okay, now, M really makes me want to just break down and cry.
I don't know
Are we
how
really gonna
she
do
set up
it?
this
Why
chalk
not?
on her.
Because I don't want to.
How is the chalk in the laptop?
Yeah, for real.
Wait, so here's the wheel, right? The wheel's on the bus.
Okay, so M says we have to figure out the speed
Does this
by
make
squaring them and square rooting
You know what they're
them.
saying?
I thought it was just on the bike, it was like on the tire.
Gosh darn.
Oh,
Oh, we're
So-
plugging in the hole.
Yeah. So 70 pi plus, I don't even know if we have the ability to do this,
I don't get
So why are we trying?
Or is it on
because
like
we have to find out.
the port, and it's like a long shot.
So
and it's
why
just
are we
tracing.
Why don't we just give up on life?
So I need to take that whole thing and square it, because that's x prime of t, right?
Yeah.
And then I need to take the other one and square it. Oh, it's gonna be
Negative
good.
70.
What is it?
Negative 70.
I don't want the second derivative. Is this the first
That's
one?
the first one.
Okay, negative
Negative
70.
70 pi cosine
Cosine.
of negative 2 pi minus 2 over 2.
Swear.
And that whole thing is squared.
That's gross.
How about if we just leave it at that and not simplify?
Okay.
Okay? We did. We just found S of t. Okay, during the first 2 seconds, how many times will the speed be equal to 50 centimeters per second? So then we have to take that and set it equal to 50 and solve for t.
Are you serious? Is that even possible?
It is, but we're not going to do
Come on.
it. No
Are you
way.
serious?
I don't want to do that. Are you kidding me? You have to square both sides.
What?
And then you have to foil the whole
Okay,
thing
go ahead,
out.
Austin. You do it. Alright.
He's got Tourette's.
No, that's right.
I would feel bad if you actually
No, wouldn't.
I feel bad for us. Nobody else do.
I'm breaking this damn pencil for making me mad that I can't do it.
You're going to like break your hand in the process. All right, number 14.
Hurts.
Did not get the medication today.
I took medication.
Number 14, a metal rod 1 meter in length
Be like
is placed horizontally on the x-axis, focus now, with its ends located at P00 and Q10. So the distance between P and Q, that's a metal rod, okay? A second long metal rod is attached to the first one at the point Q equals 10 and makes an angle of 45 degrees with the first. A third long metal rod is attached to the first rod at point P equals 00 and is free to rotate about P. Thus, the angle theta made by the first and third bars is free to change. So let me see if I can
Did you draw this
explain.
picture for us?
I did, yeah. Let me
I
see
don't
if
think I would have been
can.
able to draw this just from the
Okay, so this is a fixed rod of 1 meter's length. Okay?
What would I do?
Remember that guy that like at the railroad or whatever, and he had like a metal rod, like a tamping rod, and then they moved that down and blew up and it
Oh,
through his
did he
hand.
use something?
Yeah, he just gave it.
Yeah. What about it?
Oh, this just reminded me of it because it said metal rod.
Alright.
I just remember his name was Phineas because Aaron said people always asked him which name. Why did you leave? I don't know.
I think I might be in it with you.
Oh, yeah, probably.
I try to go to sleep sometimes.
Okay, so here's what's going on. This is our situation, okay? This is a metal rod 1 meter long and it's fixed, okay? This is another one that's fixed at a 45-degree angle, all right? And then what we're going to do here is we're going to take this rod right here, and it says it is a third long metal rod is attached and it's free to rotate about P.
Whoa,
So this,
You did a fancy
so this rod right here, you can, oh, lost it, rotate it up and down.
Your little rotator.
I know, huh?
Oh!
Epic fail. This one I had it going. And so what they're saying then is that this angle in between this one and point P here, which they creatively called theta, is going to change. Does that kind of make sense?
Well,
I don't know why. I don't understand why we want to put all these metal rods together this way, but that's how we've done it. Go.
Make that
Isn't it
equal.
equal to like, if that R was an angle, like the letter R is half?
Oh, is this theta equal to R? Is that what you're saying?
no, it's going to keep.
This angle right there?
Yeah, that is.
No, because you would need these lines to be parallel for that to happen, and that's not going to work. Yeah.
We found a situation that we could use for
Not really.
Come on.
I want to hear the situation. Need this situation.
Yeah. Okay, so there's, so can you not?
All right.
I
So
just-
we have a crossing pressure. All right. So part A. Let's do some math here now that we understand what's going on.
Yeah.
Find the relationship between x, y, and theta, and x and y are the coordinates of that point right there where the two things intersect. Then eliminate y by expressing y in terms of x. This gives you a relationship between x and theta in the form 1 minus x equals. So what is our relationship between x and y and theta in this picture? But it's not a 90-degree angle, right?
So R is.
Oh, I guess you're right. Yeah, because you can draw this down here, and so it will be. And so if this, you made this be the origin, like that. Yeah, because it says 0, 0. Okay, good. Never doubt Kayla. What was I thinking? And so this distance is always going to be x, and this distance is always going to be y in your right triangle. And so that means that the tangent of theta is equal to the opposite side, which is y, divided by the adjacent side, which is x. Now, where does the 1 minus x come in?
Well, you're supposed to do it in terms of x.
Oh, I know where the 1 minus x comes in. Say that again? The whole length of the thing is 1. And so instead of calling this x, did they call it 1 minus x?
Yeah.
So they want this. Why would they do that? No, this distance over here would be 1 minus x. Right?
For example,
Huh?
you could.
Well,
Y has to be in terms of x.
Then eliminate y by expressing y in terms.
45, 45, 90 with y.
Okay, beautiful. So since this is a fixed angle 45 degrees, then that means that as this bar rotates down this way, that's kind of weird to think about, it doesn't seem like it, but that means that this angle is going to stay at a fixed 45 degrees somehow? The angle straight down from there? Okay. Yeah, that makes sense. I'm good with that. All right, so Julia says that that means that y equals 1 minus x. Awesome. So I can rewrite this as the tangent of theta equals 1 minus x over x. And then multiply both sides by x. So this gives you a relationship between x and theta in the form 1 minus x equals x tangent theta. Okay? Whew! Man. All right, B, notice that x equals 0.5 meters when theta equals
0.5
45. What?
What?
What? What is that?
I just said 0.5 meters.
Oh, okay. And so what they're saying is when this angle right here is 45 degrees, that's when this point of intersection is halfway in between, right? Okay? So that's when x equals 45. Approximately how many radians should you increase theta? If you want the x-coordinate of the point R to decrease by x equals 0.45 meters, use the tangent line approximation.
Probably somewhere around like.
So what did we have going on for our linear approximation thingy yesterday? What was that thing?
Oh, yeah.
L of x equals
I got it.
f of a plus f prime of a, because that's the slope, times x minus a. Okay? And so how does that help us, I wonder?
Well,
They want us to approximate. Yeah, use the tangent line approximation. Maybe that's not what they want us to do. Let's do it let's do it an easier way and just hope that it's right. So let's take the derivative of that. That seems pretty safe, doesn't it? Doesn't it? Okay. So what are we going to do? The derivative in terms of approximately how many radians should you increase theta? So we need the theta, the theta dt, or don't it be theta dx? Now you're just being dumb. Let's take the derivative. Let's figure out what the theta dx is. Okay. So that means that x is our independent variable or whatever. So the derivative of 1 is 0. The derivative of negative x is -1. Then I need to do the product rule here. So the first one times the derivative of the second one. What's the derivative of tangent of theta? Secant squared theta. And then I need the theta dx there, because I'm going chain rule, plus the second one, which is the tangent of theta, times the derivative of the first, which is just 1, and that would be dx, which nobody cares about, so we'll just leave that alone. So now I'm going to solve this for d theta dx. No idea if this is correct. So -1 minus tangent of theta equals x secant squared theta d theta dx. Divide both sides by x secant squared theta. What's secant? 1 over what?
9.
Yeah, sorry, we'll just leave it like that. So my derivative is going to be -1 minus tangent of theta over x secant squared theta. So by approximately how many radians should you increase theta if you want the x coordinate of the point R to decrease to x equals 0.45 meters? Huh? No, I don't want to do that. So maybe that derivative was unnecessary. That's what I'm thinking. So you guys have it written down in case we need it, right? So let's get rid of this. And then let's say when we plugged in 0.5 to here, you get theta equals 45. If I plug in x equals 0.45, what do you get for theta? Is what I'm asking, yeah. So 1 minus 0.45 equals 0.45 tangent of theta. So 1 minus 0.45 is 0.55. Divide that by 0.45. And then take the inverse tangent. And apparently we want to be in degrees here, because the first thing they listed was in degrees. Okay? So what's the inverse tangent of 0.55 divided by 0.45?
17.
No, I'm hoping it's going to be close to 45 degrees.
41.6.
Did you get it? Okay, works for me. 50 point what?
7.
Okay. So 50.71. So by approximately how many radians should you increase theta if you want the x coordinate of the point R to decrease to 0.45 meters? So if we started out with when x equals 0.5, theta equals 45 degrees, how many degrees did we have to increase this by? 5.71, so change that into radians. So go 5.71 degrees times pi over 180. What? 0.099. Perfect. 100% sure that's correct.
So, 1/10 of a radian.
Wait, show us your swimming please.
No, I'm not gonna. All right, so we're done. Wow, that went fast today. Did that go fast today?